There are several ways to think about mathematics and what's the most fundamental aspect of mathematics. And one such, framing of mathematics is to argue that functions themselves are the most fundamental thing in all of mathematics, right? And I don't know if I completely fall into that camp, but I'm certainly very close, right? Functions are extremely important to mathematics, all branches of math, really, depending upon how you build them up. In fact, you could think of calculus, for example, as the study of functions that map real numbers to real numbers, right? Basically, calculus is the study of functions. So yeah, functions are deeply, deeply important to mathematics. So what is a function? And you can define a function in so many ways. We could spend an entire day just on definitions of functions, really probably a week. But let's just give a nice simple definition for now, one that works for us. And the more classes you take as you go through your mathematical career, the more definitions of a function you'll get. So let's try this one. A function is a set of ordered pairs that assigns each x value in the domain to exactly one y value. Okay, that's one way of looking at a function. It is kind of a machine or a program that takes every x value in what we call the domain and assigns it to exactly one y value. Okay, so it maps x values onto y values. All right, there's a lot of visual ways of looking at this, but maybe something like this. Here we go. Okay, it takes a point. This function maps this point to another point. We'll call the one that goes into the function x and the one that comes out of the function y. And oftentimes we write a function as f. It's kind of reserved for functions, or you could write this as f of x in this case, though functions don't have to be functions of x. They can be functions of time. They can be functions of all kinds of things. But we'll start with just saying, okay, x goes in, y comes out. And that immediately brings up the question of what is a function and what's not. And if you have the graph of a function, there's a really useful trick in determining which graphs represent functions and which don't. It's called the vertical line test. The vertical line test states that if every vertical line that can be drawn crosses the graph at most once, then the graph represents a function. If any vertical line crosses more than once, the graph does not represent a function. And really, the vertical line test makes more sense with pictures than trying to just say it in words. So let's take a look here. So I am going to draw a function. Let's just draw a line. Okay, so there's our grid. There's a nice line. Okay, and what the vertical line test says is that if we take a vertical line and run it back and forth over our function, so our function is this line here, and I'm taking this vertical line, and notice how at any point, right, it only crosses once. Okay, so here it only crosses once. So that's okay, right there, it crosses. Okay, we can move it anywhere, and it's going to be the same thing, right? Move it up here, only crosses once, crosses up here. So the graph of a line is a function, right? Only crosses once, so we conclude that the function represented by this graph, the graph isn't necessarily the function itself, it represents a function. So we'd say this graph represents a function. Represents a function. Okay, wonderful. Let's try another one of these. Let's do a graph. Okay, here's my grid lines. All right, how about a sideways parabola? Okay, and you can probably already guess how this is going to go. You may be able to see the problem already. Let's bring our vertical line down here. Okay. Oh no, look what happened. It's pretty quickly fails, right? Right here it crosses at 2 points. Okay, so because it crosses twice, it just has to happen once that it crosses twice. If it crosses twice anywhere, we say that it's not a function. So this graph does not represent a function. Okay. And that's a lot of words. We end up saying this graph is a function, is not a function, instead of does not represent a function and all that. Right, and you can probably come up with a bunch of these on your own, but let's try some that are a little strange. Well, okay, let's try absolute value. This graph right here, this V-looking thing, this is the absolute value graph. Here's our vertical line. Looks good, looks good, looks good. At no point does it cross twice, right? Everything's okay with that one. So we say, yes, this is a function. Function, okay. How about a circle? Right, and you can imagine these get pretty fast. There's my kind of sad looking deflated circle here. Imagine this is a perfect, nice little circle. Take our vertical line here. Let me see if I can just grab this one. Yeah, over it comes. Crosses twice, doesn't it? Oh, whoops. Go back to here. Okay. Not a function. Okay, I think you're getting the idea of this. There's a couple really strange cases I wanted to share with you, or at least cases that could possibly throw you off. This one's going to be a horizontal line. Okay, so I'll draw it in green so it's not confused with our grid line. Okay, we grab our vertical line. Okay, and bring it across. No problems with that crossing our green line twice. It only crosses once at every point. So indeed, this is a function. A horizontal line is a function. Okay, let's try it with a vertical line. All right, so here we go. There's our grid lines again. And here's a vertical line. So let's see what happens when we apply the vertical line test to this line here. Well, it fails really, really bad, right? These lines line up on top of each other. So not only does it cross once, which is or more than once, which is a problem, it crosses an infinite number of times. So this profoundly is not a function, right? We come here and does it cross twice? Yeah, it crosses an infinite number of points right here. So while a horizontal line is a function, a vertical line is not. This green thing here, not a function.